In this video, we're going to take a look at the orbit dynamics operator. I'm going to go ahead and create our first dynamic set, use a black box called draw RGB. This just creates a bunch of particle groups that are colored for us that we can use. Come into this draw RGB. Let's go ahead and draw. First, we'll draw just one red, and then one green. Let's see where that red is. Put the green right there. Okay, and then we'll go ahead and create another dynamic set. And let's go ahead and name this dynamic set orbit. And we'll go ahead. Now, in order for these two particles to know about each other and to figure out which one should orbit around the other, we're going to go ahead and use an initiator. We'll use PPassAB. This is probably one of the most powerful initiators next to psearch and iterator. This is very commonly used anytime you need interaction between two particle groups. You're going to want to use PPassAB. You do not want to try to use two actual group operators here like this. You generally, these are also considered initiators. They are the PPass type. This is where you can actually specify just a single particle group, and you only ever want to be using one of these in a dynamic set at a time. Is a good rule to follow. Anyway, so we're going to go ahead and use PPassAB. First, we're going to say we want the red group to be group A and the green group to be group B. We're going to go ahead and calculate all of them, so every red compared to every green. And what we want to do with that is we'll go grab this dynamics orbit, drop him out here, and let's go ahead and we'll affect the green particle and have the green particle, which is the B particle, have him orbit around the red. So that's why we're telling the B particle, hey, I want you to be the one orbiting. And we want to have him orbit around a certain position. The position, we can go ahead and just drag this A particle and drop him on the position. Now this is not actually the A position output, but what something new in TP3, if you go ahead and just use the particle input to these things, it'll automatically go ahead and pull that position information. Okay, and so you can see by default the orbit is very slow. So let's go ahead and actually we'll make that the angular speed or angle speed. You can see it goes quite a bit faster there. And we'll go ahead and increase this. So we can see that particle is, let's go ahead and move around here. A green particle is just doing circles around that red one. Let's go ahead and stir it up a little bit. Let's say that we want the red particle's alignment also to affect that. Now at this point both these particles just got drawn and they have no extra alignment information, so you're not going to see any difference. But if we go ahead back here and actually we'll go ahead and create a new rule because we want to just isolate the red particle. We're going to move him above here. We'll call this red spin, and what we'll do is go ahead and grab the red group and we're going to add a dynamics operator spin. And we're going to go ahead and set him to spin at a speed of 1 in a random axis. And now what we'll see is red is spinning around and green is orbiting red. It's kind of a funky output though. It's not quite what we would expect. Generally you might want to use orbit for things like creating a planetary system. Go ahead and come up here again. We're going to create a few more green particles. And let's go ahead then and come down to the PPassAB. And what we're going to do now is, if we see it when we scrub, all we see is one green particle, but you know that we just drew a whole bunch of extra green particles. What's happening is orbit is forcing all those particles into the same position in orbit. You can tell because if we adjust the speed variation, we can see all those particles kind of separate there. So this is one of the things to be aware of with orbit, is that you're going to want to modify these parameters to kind of shape the effect how you want. And let's change the speed variation. We'll go ahead and see now that as we go ahead and scrub, these guys are going to fan out, and we actually probably don't want them to go too slow. change some alignment variation, because right now you remember we're also using that red particles, group A, the A particle. We're using his alignment to control the orbit, and adding some variation is basically just going to push them off his axis a little bit. And you can see they kind of go up and down and alter their orbit around him. Kind of different planes at angles there. And then there's also the position variation, and this modifies this position here, adds some variation to it, so it's not all going to be centered around the red particle. We can go ahead and modify that quite a bit. Let's change the alignment variation back to 0 there. Change this to the top view. And you can see that the position variation is also going to add some height and different orbit to them. But that is not actually at an angle at all. That's just going to be pure height value. Then there's also the center variation. So the center of the orbit, which is actually the actual complete position of that red particle. And if we change that, then that's going to kind of make that center position anywhere within a distance of 12.43 from that original position. So it'll create an entire kind of sphere around there. So anywhere, these particles will be orbiting any position anywhere inside here. So that's kind of the basics of orbit. Orbit's great. You can actually do some things where we won't set them up here because they're pretty involved, but you could have a particle fly into space, into the space of another object, and actually go ahead and assume his orbit at that point. So there's quite a bit you can do there. Let's go ahead and just take a quick review of the inputs. You can see he's got all these available inputs, and so you can modify these dynamically, driving other data, maybe make the particle age, control the speed. Okay, so let's go ahead and move on.